Second mastery test today will be our homework. It's called linear equations. And I'm adding this in myself and translating and solving word problems. Okay, one moment while I get my thing fixed. Translating and solving word problems. So, whenever you see linear equation, what that means is just an equation with one variable. So there's going to be one letter, like X or Y or A or B, that we're solving for. So when we get to the end, it should say X equals something, A equals a number, something like that. Linear equation. So let's start with a few examples, and then we're going to talk about why that works and how to approach any problem, even if it's a harder example. So start with this one with me. Example 1, A plus 4 equals 17. A plus 4 equals 17. So now it's not just simplify the expression, it's solve for A. I'm sure that some of you are looking at this and have already solved it, probably just in your heads, or maybe you did it on paper. Would anyone be willing to tell me what you got for A? A plus 4 equals 17. Nobody? I see something in the chat. 13. Awesome, Philman. Thank you. Yeah, and I would like to ask you, how did you get that? How did you see that that is 13? You probably kind of counted backwards from 17 until you got 4 spaces away. Here's how I'm going to show you guys how to officially do problems like this. Locate, and this is probably what Philman did in his mind, even if he didn't do it exactly the way I'm going to describe it, but it is the same or very similar. So I want you to start by locating what is happening to A. What is happening to the variable? Well, hey, good. How are you? Go ahead and grab some paper and pencil. This is our first example for today. Awesome. Thank you. So what's happening to the A? 4 is being added to A. So identify what is happening to the variable and then do the opposite, the exact opposite of what's happening. So in our case, that means do the opposite of adding 4 to A. So what's the opposite of adding 4? It's subtracting 4. It's minusing 4. So I'm going to just move my problem down below here. So here's our problem, and I'm going to identify what's happening to the A, and then I'm going to do the opposite. And another note, we have to do this opposite to both sides. So what I mean is both sides of the equal sign. We do it on the left side and the right side of the equal sign. So on the left, we've got 4 minus 4. Those are like terms. 4 minus 4 cancels out to 0. So technically, we have A plus 0. On the right side, we've got 17 minus 4. There's that 13 that Philman said. He's right. On the left, A plus 0, we don't need that 0, right? It's kind of redundant to show plus 0. So I'm going to simplify further and delete it out and just say A equals 13. And what we just did is solve the equation, the linear equation for A. Some people just joined. please, I'm glad to have everybody who's just joined. Please grab some paper and pencil. Turn off those mics until you have a question. And if you have a question, I want you to turn it on and jump in and ask me, please. Or if you prefer, you could type it in the chat. Okay, any questions right now? Comments, concerns about this example and how I did it? Okay, let's look at some more. Oh, and I should have done that first. So identify what's happening to the variable. And when I say what is happening, I mean any operation. So specifically, is it being added, subtracted, divided, or multiplied? And then, like I said earlier, we do the opposite to both sides of equal sign. So here's example 2. Identify what's happening to the f. Well, it says f minus 6. So I don't want a minus 6 from both sides because minus 6 and minus 6 won't cancel, right? That's why we're doing opposites. So I want to do a plus 6 to both sides. I identify what's happening to f, and I do the exact opposite of that to both sides every time. This will always work. So 6 minus 6 is 0, meaning it's just f all by itself. Yay, that's what we want. On the right side, we've got 21 plus 6, so 27. Now, this move we're doing by adding 6 to both sides, it has a name. Technically, this is called the addition property of equality. I'm going to write that out here. Addition property of equality. That's what we're using when we add 6 to both sides. What it means is, as long as we have two things that are equal, then we can add the same thing to both sides and it will keep it equal. It'll keep it true. It's kind of like if we had a balanced scales hanging here with two things on both sides and they weighed the same, right? But if you wanted to keep them level, then we would have to add in or subtract the same amount from both sides. So this is me like adding 6 pounds to both sides of my scales. As long as I do the same thing to both sides, it keeps it equal and it keeps it even and it keeps it true. This name, you don't usually think about it, addition property of equality. But it is the formal name, and in our mastery test, it's going to ask us about, well, which property did you use? Was this subtraction or addition or multiplication or division? So real quick, in the last example here, we used the subtraction property of equality. This is our example 1. Here we use subtraction property of equality. We minused 4 from both sides, and that still kept it true, and it allowed us to find a is 13. So whatever move we make, we're technically using that property of equality, either addition, subtraction, multiplication, or division. Here's example 3. 10m equals 80. Now remember from last week, if you have a coefficient like 10 right next to a variable like m, well, that means multiplied. So what's happening here is 10 is being multiplied to m, and that equals 80. So what's the opposite of multiplying by 10? Dividing by 10. So I need to divide 10 from both sides of this equation to get rid of that 10 times m. So 10 over 10 is 1. Remember, anything divided by itself is 1. So I'm going to cross those out and cancel them. Because technically what we have here is 1 times m. On the right side, we've got 80 divided by 10. That's 8. So here's our answer. M is equal to 8. What property did we use this time? In step 2, or really step 1, the first thing I did was the division property of equality. I divided the same number from both sides. Okay, I'm going to really quick pull up my screen to see everyone. I would like to see thumbs on to know where you all stand with this so far, these first 3 examples. So if you can, I would really appreciate you giving me some feedback here, just so I know how you're feeling. Jaden, I see that. Thank you for your feedback. So if you can, hit your camera on and just show me your thumb. A thumbs up means I'm feeling great, I understand, and I feel comfortable with what you've done. A thumb sideways is like, I'm kind of getting it, but I need more time. And thumbs down, you know what that means, right? That means I'm terrible and I hate this and I don't want you to do math with me anymore. But I need to know. Thank you all. Bearcat, I see that. Robel, thank you. Maddie, I see that. And Tira, thank you. Levi, I see your feedback too. Thank you. Baniam, I appreciate that. Anthony, thumbs up. Thank you, Anthony. Aaron, Anaya, I see your feedback. Okay. Thanks, everybody. So yeah, this is probably review maybe for some of you. You've seen it before. And if not, then I'm glad you're still with me. Okay, now here's example 4. And often, obviously, we're going to have more complex problems like the last 3 that we just did. So this one's slightly more complex because there's more than one action happening to the b, to the variable. So I'm still going to ask myself, okay, what's happening to b? Well, 2 is being divided. So that means I know I'm going to be multiplying 2 to both sides. And we've got 3 being added. So that means I'm going to be subtracting 3 from both sides. Generally speaking, I like to work from the farthest away and get closer, one step at a time, to the variable. It technically can work no matter which order we choose, but it can be a little cleaner and easier to do if we work from farther away and get closer. So that means, and just to demonstrate this, you don't have to copy this down, but just to demonstrate this, I'm going to kind of circle my variable and then circle the next closest thing and then circle the next closest thing. And it's kind of, yeah, please. Thank you for telling me. Here we go. Okay. Billy, sorry about that. Thank you for joining. Didn't recognize the screen name, so I just kept you out. But I appreciate you sticking with it. Totally. It's okay. I'll try to remember that if I see it again. I just thought it might be some, internet troll just trying to hijack, it happens. Anyways, thank you for joining. So, the reason I'm circling this stuff is just for me to help me see which one is farthest away. Usually that means the one being added or subtracted. We want to do that first. So the 3 first, and then we'll deal with the 2. Anyways, let me start over and we'll do it cleaner. So here's our problem. So I've identified what's happening and I've identified which one's farther. It's that plus 3 is farther away. So I'm going to start by minusing 3 from both sides. Now remember like terms. So in this case, the minus 3 is not going to deal with that b over 2 because the minus 3 is like a whole number and there's no b with it, right? It's just the 3. So it only is going to affect or kind of like work with this guy because it's also just a plain whole number. 3 minus 3 is 0. So those are gone. We're going to cross those off. It's a 0. So what's left? We've got b over 2 is equal to 15 minus 3. So we figure out what that is. It's 12. And now it's like the first couple problems. Now we've got to undo this division. So think, what's the opposite of division? It's timesing, multiplication. So I'm going to multiply both sides by whatever's in the denominator, which is 2. 2 over 2, that goes away. It's 2, it becomes a 1, right? So we have b is equal to 24. So by the way, this was a two-step problem. We did minus 3 for both sides, and then we did times 2 to both sides. So what did we use in this problem to solve it? We used the subtraction property. I'm just going to say prop of equals. And we used the multiplication property of equality. Just by the way, keep that in mind. Like, let's be conscious of what we're doing while we're doing it. And that's what we did. We used the subtraction property of equality, right? We minus 3 from both sides. And then we did the same thing for multiplying 2 to both sides. Okay. Any questions, comments, concerns? Please. Let's try some more. And then we are going to get into translating word problems and then solving those word problems. Just wanted to give you all a heads up. Okay, here's another more complex question. We've got stuff on both sides of the equals, and there's x numbers on both sides of the equals. So this is a little different. So step one, whenever you've got a question like this, is think to yourself, I want to get my x's on one side and my non-x's on the other. I want my problems to look like those simpler ones we started with today. And right now, this doesn't look like that. So I want to move my x numbers to be together. So let's think about it this way. I'm going to move my 2x to the left, and I want to move my 7, my negative 7, over here. That'll be like whole numbers, and then my x numbers on the other side. That's kind of what my mind's doing. I'm thinking, okay, let's move my x's one way, my whole numbers the other way. I'm going to start over here. So it'll be a little cleaner. So I've got negative 7 plus 3x is equal to 2x plus 23. So this will take a few steps. So to move my 2x over, remember, you can't just pick it up and drag it. You've got to use your properties of equality. So I'm going to minus 2x from both sides. Now, like terms kick in here. So 2x minus 2x, those are interacting. They get to cancel out. They cancel out because 2x's minus 2x's is 0. So on the right, we're just left with 23. Cool. On the left, we've got negative 7. Okay, now this is tricky. 3x's minus 2x's. How many x's are left? It's like saying 3 minus 2. It's just 1. So 1x. Okay, technically it's a 1x. I'm going to actually get rid of that 1 on my next step because 1 times x is just x. Okay, now this looks like one of our first problems. It says negative 7 plus x equals 23. Now, I said to always do the opposite of what's happening to the variable. So if this is being added to negative 7, what would be the opposite of that I want to counteract that negative 7 with? A positive 7. I want to crash positive 7 into that negative 7. So I want to add 7. And if I do it to the left side, remember, I've got to do it to the right side for the property to work, for the scales to stay balanced. So we get x is equal to 30. I'll write that up here. X is equal to 30. By the way, we haven't done this yet, but you can check your work. When you solve it and you get like X is equal to this number or A is equal to this or whatever, then if you start over from the beginning and you plug in the number you got, it should balance. So really quick, I'm going to show you what that looks like here. I know you've probably seen it before in other problems, but here's what that means. So I'm going to say check work. So what's the original? Well, it's -7 plus 3x equals 2x plus 23. Okay, and I just solved it and said x is equal to 30. So I'm going to check and see, is that even right? I don't know. Let's find out. So I'm going to switch out 30 for wherever I see an x in the problem. So I'm going to say -7 plus 3 times 30, 2 times 30 plus 23. Okay, so we've got -7 plus 3 times 30. That's 90. Try it on your calculator if you need to. 2 times 30 is 60. Okay, so now 90 minus 7, 83. Does that equal 60 plus 23? It sure does. 83 equals 83. We're just checking. Because these came out equal, that means the number we plugged in was good. It was correct. If I plug in some random number for x instead of 30, then we're going to get something that's not true, like 40 equals 83. And that's not true, right? So that means what I plugged in there was incorrect. So it doesn't mean our answer is 83. It just means that it balanced because we had the right solution for x, the right value. Any questions or concerns? Please. Okay. And remember, if you do want to type it in the chat, that's all good. And if you want to interrupt me and ask, I would love that. It's okay. Okay, I've talked about this, so I might not spend any more time on it. When we add, subtract, multiply, or divide to solve an equation, we are using the properties of equality. So just like we saw earlier, it's good to think about which property you're using. One, because the mastery tests you're going to take today and tomorrow are going to ask you. And two, it's good to be conscious of what we're doing and know why we're doing it. So these are from earlier. You don't have to write these down. These just show you those different properties. So here we would -4, the subtraction property. And then f minus 6 is 21. Well, you have to add to solve it. So what did we use? The addition property. Okay, I think people are doing okay with that based on the thumbs. Okay, now I think we're going to get into some word problems. It's almost 11:30, so let's do these word problems. I'd like to be done in 10 minutes or so that we can all try our mastery test today together before you go. And that way, if you have a question, just tell me the question, or you can share your screen, and then I'll be happy to talk you through it or answer your specific question. Okay, so this is not the name of like the mastery test, but I added it in because I think it should have been part of the name of today: translating and solving word problems. So here's how I like to do my word problems. I want to read the whole problem from top to bottom, and then I want to read it again and write down the math parts as you read, kind of like from left to right, okay? And I'm going to demonstrate what I mean now. So we're going to read it through once, and then we're going to read it a second time, writing it down as we go. The good news for today is that all the mathy word problems we're going to do are going to correlate to problems like these. Linear equations that are not too crazy, okay? They're just like 1 or 2 steps each. Most of them are just one. Here we go. Let's try this. And another thing I want to say is I don't want you guys to write down these whole word problems from my notes. It'll take too long. I'd like you to follow along and try doing the math with me. But just take a picture with your phone or a screenshot if you want to have this word problem for later. So here we go. A school administrator bought 6 desk sets. Each set consists of 1 table and 1 chair. He paid $48.50 for each chair. If he paid a total of $663 for the 6 sets, the cost of each table is what? So now I'm going to read it again and write down different mathy parts that I read as I go. And you know what? I'm going to underline any numbers I see that those will be used as well. So a school administrator bought 6 desk sets. Each set consists of 1 table and 1 chair. So I'm going to try to draw this out. We know that each set is a table and a chair. Okay, that's what we're calling a set. It says he bought 6 of these sets, right? So I'm going to do 6 times my table and chair, my set. 6 sets. Okay, then it says he paid $48.50 for each chair. Each chair equals $48.50. If he paid a total of $663 for the 6 sets, what is the cost of each table? So 6 times the table and chair sets is equal to $663. It didn't say that outright, but it is implying it. He paid a total of $663 for his 6 sets. So I'm going to write that down below. 6 table plus chair is equal to 663. We also noted that each chair individually is $48.50. Now, looking at my word problem or my math that I've got so far, in the set, in the parentheses, I've got table plus chair. So if we knew the cost of each table and the cost of each chair and added that together, that would be like 1 set. And then 1 set times 6, we know, adds up to $663. So I'm going to substitute $48.50 in for wherever I see chair in my what I'm trying to throw together for my math down below. So let's see what that looks like. 6 times, I'm just going to say, I'll say the whole word. Table plus $48.50 equals 663. Okay, now this, albeit is rather complex, but this is a linear equation. Remember, a linear equation is just any equation with only one variable. Now, you might be saying, well, there's not a variable here. But remember, the variables are numbers that we just don't know the value for. Kind of like how table is standing in for the price of a table, but we don't know what it is yet. So our variable is table, or T for table. Or you could write it as X. It could be anything you want. But we're treating table like it's just the price of a single table, just like we did with chair. Okay, so how do I solve this mess? I'm going to change my color real quick to yellow. Okay, so we can start by, last week we saw distribution, where the 6 right next to the parentheses, that's being multiplied. So we can multiply 6 times the table and 6 times the $48.50. So I think I'd like to start like that. So that'll be 6 times, if it's okay, I'm going to say t for table. 6 times table plus 6 times 48.5. So let me do that in my calculator. I don't know what that is. 291. So that's 6t plus 291 equals 663. Okay, now this doesn't look too bad. This looks just like our earlier problems. Identify what's happening to the t and undo those actions. Farthest away action is plus 291. So we're going to minus or subtract 291 from both sides. Okay, so 663 minus 291 is 372. So 6t is equal to 372. Now we divide both sides by 6. 62. T is equal to 62. So that means the cost of each table is $62. And if we wanted to, if we needed to, we could plug this in, 62 in for table, and see if that comes out even. It should come out to 663 on both sides. Okay, maybe I shouldn't have started with this problem, but I think it is a good example of the kind of stuff we're going to do. Any questions, comments, concerns, please? Thank you, Tira. Okay, let's try a couple more. Okay, example 7. Again, please don't write the whole thing down. Maybe just take a picture. Cheryl has a basket of ripe apples and peaches. The number of apples in the basket is 16 more than twice the number of peaches. If there are 28 apples in the basket, there are how many? There are blank peaches in the basket. Okay, so now I'm going to read through it again and try to underline stuff that looks important, any numbers and any relationships, like apples versus peaches, anything like that. And let's try to write it down as we go, just based on how we're reading it. So Cheryl has a basket of ripe apples and peaches. So far, my mind goes, okay, we've got this basket or bowl with our apples plus our peaches. The number of apples in the basket is 16 more than twice the number of peaches. Okay, hold on. Whenever we see the word is, that's equals. Equals and is, same thing. So the number of apples in the basket, A, equals 16 more than means plus, bigger. A equals 16 plus. Then it says twice the number of peaches. So how do I write twice peaches with math symbols? It's 2 times peaches. 2p for peaches. So far we've only made it to the second sentence, right? We're here. If there are 28 apples in the basket, there are how many peaches in the basket? So this is telling us what to substitute in for A for apples. I'm going to now plug in 28 in for A. And now this thing has become a linear equation because there's only one variable and we can solve for P, for peaches. Word problems are tricky, but the best way I can approach it is by reading through it again. I like to circle any numbers. I like to identify anything that sounds like math, like more than or less than or double or twice than or something like that. Any numbers or any relationships should be identified. like I tried to do here today. Okay, and now we can solve it. So farther away, what's happening to the p? Well, 16 is being added and 2 is being multiplied. So we're going to have to undo both of those. We're going to minus 16 and divide by 2. Farther away is the 16. So start with the farther away and then work closer to the variable p. So this is 12. So 28 minus 16. We've got 12 equals 2p. Divide by 2 and there should be 6 peaches. The equations themselves, not too bad, right? The word problem is the harder part, I think. It's like, okay, how do I start this? How do I find what my equation is? It's hidden in there, but you've got to try writing down what you read as you read it. Any questions? We're going to try another one. Okay, I think I've got 10 total. Let me check. Yeah, let's do number 8. And by the way, these problems are all from the mastery test today. I did change the numbers on some of them, but it's the same exact problem. Molly has $60 in her wallet, which is 3 times as much money as her brother has. Write an equation to represent this situation, where A represents the amount of money Molly's brother has. So A is supposed to be Molly's brother's money. Okay, Molly has $60. Is equals 3 times as much money as her brother. So 3 times as much money as brother. So I'm going to say 3. Well, my first thought is to say 3b because 3 times brother. Okay. This problem is telling us later A is supposed to represent the amount of money that the brother has. So for me personally, I would have written this as 3b. Something equals 3b equals 3. And then what is the 3 times? It's the amount of money the brother has, so 3b. But pay attention because sometimes in a math book or a math test or Edmentum or whatever, any school you ever go to, there's going to be a problem like this where they tell you where they want what variables they want you to use. In this case, it's A. So I'm instead of saying 3b, I'm going to change that to 3a. So here's the math I have so far. Equals 3a. Okay, it seems a little bare. What am I missing? Oh, Molly has 60. 60 equals 3 times A. I think that's it. There's nothing other, there's no other numbers that I didn't deal with or like didn't put into our writing. And now you can see how to solve this. We're going to divide. Opposite of times 3 is divide by 3. So Molly's brother has $20. Molly has 60. Okay, next. Let's do another one. Number 9. Frederick manages a band and sings lead vocals. The band charges $700 per concert. There's some math, some numbers. Frederick receives $175 of that money, and he shares the rest equally among the other 5 members of the band. How much money does each of the 5 band members receive per concert? So not Frederick, but how many did the rest of the band get individually? Okay, so Frederick manages a band and sings lead vocals. Wonderful. The band charges $700 each concert. Frederick receives this much, Fred gets 175 out of every 700, and he shares the rest equally among the other 5 members of the band. So let me try to do this. I read this problem and I think of like $700. Like imagine the group just did a concert, so they have $700 on the table, so to speak. Frederick takes 175 of that right off the bat. So imagine that money on the table, stacks of bills right here. And then Frederick's going to minus 175 from that. Take it right off the top. Maybe the other band members should talk to Frederick about this. Maybe he shouldn't be doing that, but I'm trying to be funny. But the point is, it's the total that they have minus his 175. That equals some amount, right? So I'm going to kind of clean up what I've done in my thoughts and my notes here. I'll draw a line to keep it all separated. So let's say we had 700 minus 175, and that should be equal to some amount. I'll say just money. Okay, I'm just going to write it out. My variable would be M for money. And then it's being that money, that M for money, is being shared equally among 5 people. So that means we're dividing. Shared equally means cut up equally, right? So divide it by 5. So 700 minus 175 is 525. Okay, and then I multiply both sides by 5. Uh-oh. You know what? This doesn't seem to make sense because look what's happening. 5 times 525, that's huge. That's $2,600. So I made a mistake. Somewhere in my thought process, it sounded good and it made sense, but this will happen sometimes. So if you work out a problem to a point like this, I'm going to just dash it around here in a box. Make sure you're thinking to yourself, does this like make sense in the story? They only have $700 to start with. So where's this $2,600 coming from? Something's not right. Does anyone see, looking back through what I did or thinking through this problem, maybe another avenue, maybe see a mistake I may have made that could help us solve this? Who was that? Tira? Thank you, Tira. Yes, absolutely. So there is division in the problem, but the way I set it up didn't make sense at the end. So back up, look at your work, and then see if, well, it's like there is division. They're sharing it equally. But instead of dividing this M for money, I should have been dividing the whole amount 525, like Tira said. So I'll do that below. So 525 divided by 5, that makes more sense. That's the actual amount right here, 525, that the group has after Frederick takes his 175. So thank you, Tira. Totally on point. 525 divided by 5, that comes out to 105. And that makes more sense in the context. That's per band mate. Per band mate, right? Each person gets that much. And maybe they should talk to Frederick and not let him take that extra $70. Or maybe he deserves it if he's doing extra work. Thank you, Tira, for jumping in. Any other questions, comments, concerns? Okay, let's look at the very last one. The length of a rectangular park is 15 feet longer than the width of the park. If the length of the park is 42 feet, what is the width of the park? They're talking about a rectangle. They're talking about a park outside, right? So I'm going to draw a rectangle. The length of a rectangular park is equals 15 feet longer. That means plus than the width of the park. 15 plus width. And what am I saying is equal? Length. The length of rectangle is 15 plus width. If the length is 42, now they're giving me an actual number, to plug into that length. Below, they're giving me a real number. Length is 42. What is the width? This one's not too bad. So 42 is equal to length. So my top equation we could clean that up. We could say L is equal to 15 plus W. This is not a linear equation because it's got two variables. But as soon as they give us this number 42 and we substitute it in, it becomes a linear equation. And then you can see here, okay, what's happening to the W? It's being plus 15, so I need to minus 15 to whatever that comes out to. 27, I think. Let me double check. So W width is equal to 27. No questions. Then what I'd like everyone to do, we have about 10 minutes. Let's start the next mastery test. It is called linear equations. This is your homework for today, Monday the 13th. It's the second mastery test, linear equations. Now, tomorrow, I want to take maybe just a few minutes in the beginning to go over any other questions that people had from today's mastery test. And there's the, at 3 o'clock tomorrow on Tuesday, I have extra time set aside for my math class students. So at 3 o'clock, I'll be back on my link again. If you need help with last week's homework or help with today's homework or want to go over any example or have a question, we can do that tomorrow at 3 o'clock extra. Levi, go for it.